Second method, we are going to focus in questions that ask us about the reactants. So usually this method is easier and more practical to use when anything is related to the reactants. In this case, for example, the question asks us what is the excess reactant and how much is left over. So we can use a method 2 in that case. However, both methods are useful to answer all the questions that you can get about stoichiometry. So you can just choose one of the two methods and stick to it. You don't have to know both of them, just choose the one that you prefer, and that is easier for you. In both methods, the steps are very, very similar. So if you notice, in both methods, the first step is to convert all the quantities to moles, and the second to balance the chemical equations. The steps are exactly the same. So in this case, if we read the problem, silicon carbide is a ceramic material that tolerates extreme temperatures and is used in the brake discs of sport cars. How many grams of carbon monoxide are formed from 70 grams of silicon dioxide and 50 grams of carbon? What is the excess reactant and how much is left over? Okay, so if you notice in the question, they are asking us about a product, carbon monoxide, which is right here, and also they're asking something about the reactant, which one is the excess, which one is the limiting, and how much is left over. Okay, as the quantities are given in grams, first step you need to do is to convert to moles. So if you remember, we do that by looking at the periodic table, find the atomic masses of each of the elements, in this case silicon and oxygen. In this case, oxygen has a subscript, we need to multiply by 2, add both masses together, and then we will get that for silicon dioxide, the molar mass is 60 grams per mole. Then, based on the quantity that was given in the problem, in this case 70 grams were given, so we start with the 70 grams. We use our conversion factor, which is the molar mass, 60 grams, 1 mole, 60 grams, that's our conversion factor, and we turn it into moles to obtain 1.16 moles of silicon dioxide. And then repeat exactly the same for carbon. So we have 50 grams of carbon, the atomic mass of carbon is 12, so 50 grams of carbon multiplied by the molar mass, which is 1 mole equals 12 grams, we obtain 4.16 moles of carbon. That was the first step, converting grams to moles. In the second step, we have to balance the chemical equation. So to balance it, we need to add a coefficient of 3 for carbon and a 2 for carbon monoxide. If you notice, as usual, the element that was not balanced was oxygen, so that's why we had to add a coefficient in here to balance first oxygen, and then we obtain 2 carbons in here, plus 1 in here, 3, so that's why we need that coefficient of 3. In here, we just transferred what we had from the previous calculations, because we are going to need these numbers again, so that's why I transferred again to this slide, but this was the calculation, they were the calculation that we just did before. Okay, so the third step is to consider the information given in the problem, propose some conversions to calculate what you need for the reaction. This is the section in which we call a column the given and other column the needed. So given is what the problem is telling me. In this case, these amounts that we got after the conversion. So we have 1.16 moles of silicon dioxide and 4.16 moles of carbon, our initial amounts, okay, coming from what was given in the problem, the grams. And then remember that always our reference is the balanced chemical equation. This is, in the analogy that we looked at, this is our recipe with the amounts that we need to use. So this is our main reference and our main base for these exercises. Based on that balanced chemical equation, we know that silicon dioxide, we only need 1 mole of S, and we need 3 of carbon for them to react. So this is the ratio in which our reactants need to be combined. 1 of silicon dioxide, 3 of carbon. This is always our ratio coming from the balanced chemical equation. That's what we need to do. In this method, the only difference compared to method 1 is that in here we are referring to the other reactant. Reactant 1 versus reactant 2. In method 1, we had in here the product. That's the only difference that we have. If we do this calculation, we are going to obtain that we need 3.48 moles of carbon in order to react with 1.16 moles of silicon dioxide. And we repeat exactly the same for the other reactant, which is carbon. So we had 4.16 moles of carbon that was given in the problem. And again, we compare it to our chemical reaction once it's balanced. We have exactly the same conversion factor, but switched around, because now we have that 3 moles of carbon react with 1 mole of silicon dioxide. If you notice, exactly the same conversion factor, exactly the same relationship between reactants. So that's it. That's what we need to propose. And we obtain that 1.38 moles of silicon dioxide are needed. What are we doing in here? Just calculating. If you prefer to think of a rule of 3, this is what we are doing, proposing how to solve this with a rule of 3. If I know that 1 mole of silicon dioxide reacts with 3, how many of carbon do I need if I need to use 1.16? And the same with the carbon. Okay? Think the way you prefer. If you prefer to think of it as a conversion factor, as a rule of 3, find the easiest way for you to think of it. Now, next part is to interpret these numbers. So this is the key part. Be careful in here how we are going to read the exercise, the numbers that we got. We have one column that is called given, and the other one that is called needed. That's what we are going to compare in the fourth step. We are going to compare given moles with needed moles to determine which one is the limiting, which one is the excess. So, for example, for silicon dioxide, we have 1.16 moles. That was what the problem gave me. And according to my calculations, I need 1.38 grams of silicon dioxide. The question is, do I have enough? If I have 1.16, but I need 1.38, it means that I don't have enough. Let's check the other one. For carbon, we have 4.16. That's what the problem is giving me. And I need 3.48. If you notice, I have 4.16, I need 3.48. I have more than I need. And in this one was the other way around. I have 1.16 and I need 1.38. I don't have enough. Okay? That's how we interpret those results. Do I have enough? But I don't. So, for example, for silicon dioxide, we have 1.16 as we saw, and we need 3.48, which means we don't have enough. We have less than needed. So, it is our limiting reactant. Sorry, there's a little mistake in here. It shouldn't be 3, it should be, oh yeah, that's right. 1.16, and we need, so we definitely, this should be 1.38. That's a little mistake in there in this slide. Okay, we have 1.16, we need 1.38. We don't have enough. And for carbon, we have 4.16, and we need, so the numbers were switched in here, we need 3.48 moles. So we have more than enough. I only need 3.48 and I have 4.16, so it's more than enough. That is why carbon is going to be our excess reactant. Okay, that's it. Those are all the calculations that we need to do so far, at least to determine limiting and excess. So we already know silicon dioxide is our limiting, carbon is our excess reactant. Now, if we move to the last part of the exercise, or if you double check the questions that the exercise is giving me, it asks me to calculate the moles of the product. Okay, go back to the question, read the question again, and you will notice that they're asking us for the mole of the product. So how we do that is we base ourselves on the limiting reactant. Silicon dioxide was our limiting reactant according to the calculation we just did, because we don't have enough. So that is our limiting reactant, and we take that amount as our starting point again. So 1.16 moles of silicon dioxide, which was the initial amount given in the problem, will be used to calculate how much product, because that's what determines how much product, the limiting reactant. So our limiting reactant, remember that these numbers are coming from the balanced chemical equation. So using that conversion factor, we find that the total amount of carbon monoxide that can be produced is 2.32. Now, the problem is asking me, look, the ratio is in here. So 1 mole of silicon dioxide produces 2 moles of carbon monoxide. That was the ratio that I used here to find out how much carbon monoxide. Again, rule of 3. If I know 1 mole of silicon dioxide produces 2, how much would I produce if I have 1.16? And then the problem is asking me for grams. So that's why I need to do one more conversion, which is turning the moles into grams. So this is the molar mass of carbon monoxide. 1 mole of carbon monoxide equals 28. This is coming from the periodic table, the addition of the atomic masses, and then this is the grams that we obtain. Finally, the last part of the question asks me for the excess reactant. What is the excess reactant and how much is left over? So we know already that our excess reactant is carbon. And if we go back to the exercise in here, according to these calculations, we know that our problem gave us 4.16 and we only need 3.48, which means that if I subtract these two numbers, I can find how much is left over. Because once I carry out the reaction, I'm only going to use 3.48 from the 4.16 that I have. So that's my leftover. So that's what we need to do. Just a subtraction of what I have minus what I need, and that will be my leftover, which is this 4.16 minus 3.48, which turns out to be a 0.68 moles of carbon is the excess that doesn't react in the reaction. Okay, so that's it. I suggest you don't memorize this kind of formula that I'm giving you here. This is to make it more easy to explain. But I suggest you understand what's happening, why is it the excess reactant, how do you calculate the leftover based on the calculations that you are doing. Okay, have a look at the exercise, repeat this video as many times as you need, let me know if you have any questions, and go ahead and try to solve exercises by yourself, either using method 1 or method 2. You can choose which one to use, it's up to you. Both methods will allow you to solve every single exercise and every single type of question. So that's it, let me know. Bye girls.